10 engines, a wingspan of more than 230 feet, and an 85-foot tunnel inside the fuselage where crew members had to lie on a small cart and pull themselves along with a rope. That was the Convair B-36 Peacemaker, a bomber so oversized that it felt like somebody had combined an airplane, a power plant, and a small building, then decided the whole thing needed to fly. And the B-36 was not alone. During World War II, engineers built 6-engine transports and flying boats large enough to move troops, vehicles, and supplies across oceans. The Cold War pushed bomber design into even more extreme territory. Then heavy airlifters appeared that could carry tanks, helicopters, locomotives, and industrial machinery almost anywhere on Earth. Some of these aircraft were built in tiny numbers. Others remained useful for decades. Several were so large that airports, maintenance crews, and transportation systems had to adapt around them. These are 9 of the biggest and rarest military aircraft ever built. Imagine driving a military truck directly into the front of an airplane. That was the basic idea behind the Messerschmitt Me 323 Gigant. Its nose opened like a pair of enormous doors, revealing a cargo compartment designed for vehicles, artillery, supplies, and troops. It was not built around speed or graceful handling. It was built around a much more practical question. How much of an army could Germany move in a single flight? The answer required a wingspan of roughly 181 feet and 6 radial engines spread across the wing. Even with all 6 running, the aircraft could reach only about 177 miles per hour. For a 6-engine military transport flying through hostile airspace, that was painfully slow. The Me 323 could carry trucks, guns, personnel carriers, and large quantities of supplies that smaller transports could not handle. During loading, military vehicles rolled directly toward the open fuselage while soldiers worked beneath a wing broad enough to make the entire operation look miniature. But the same proportions that made the Gigant valuable also made it vulnerable. It was enormous, slow, and difficult to protect. Fighter escorts were essential because the aircraft had little chance of escaping once faster Allied fighters reached it. On April 22, 1943, that weakness became catastrophic. A formation of Me 323s carrying fuel toward Tunisia was intercepted near Cape Bon. 14 of the giant transports were shot down. The aircraft, designed to keep an army supplied, had become a formation of slow-moving fuel tanks in the sky. That single mission exposed the brutal compromise at the center of the Me 323. Its enormous cargo hold could move part of a military operation in one flight, but its size and low speed made every journey a gamble. The Gigant was a flying garage built to carry part of an army. The Boeing B-29 was something very different. A bomber designed as one complete technological system. The Boeing B-29 did not look as strange as the Me 323. What made it remarkable was hidden inside. Its wingspan measured 141 feet, 3 inches. 4 Wright R3350 engines produced 2,200 horsepower each, pushing the heavy bomber to a maximum speed of 357 miles per hour. Those were impressive numbers for the 1940s, but the real leap forward was the way the aircraft was organized around its crew and weapons. The B-29 had pressurized crew compartments, allowing its crew to operate at high altitude without spending the entire mission exposed to the same freezing, thin air conditions found in many earlier bombers. It also used remotely controlled gun turrets connected to a central fire control system. A gunner could aim weapons located elsewhere on the aircraft instead of sitting directly behind every gun. Earlier bombers often felt like an airframe with weapons attached wherever space was available. The B-29 felt as though the engines, crew areas, navigation equipment, defensive guns, fuel, and bomb load had all been designed to function as one connected machine. That complexity came with a price. Its engines produced tremendous power, but they also demanded careful management, and long missions placed constant pressure on both the crew and the aircraft. The B-29 later became permanently connected to the atomic bomb missions against Hiroshima and Nagasaki, making it one of the most historically significant military aircraft ever built. But its importance went beyond those missions. The Superfortress showed what the next generation of strategic bombers would look like: pressurized, fast for their size, heavily armed, and built around integrated systems rather than separate pieces of equipment. The B-29 brought advanced technology into the bomber. The Blohm and Voss BV-238 tried to bring an entire heavy aircraft onto the ocean. Building a large airplane is difficult. Building one that must also behave like a ship is worse. The Blohm and Voss BV-238 was a 6-engine military flying boat developed during World War II. Instead of using landing gear and a runway, the lower fuselage was shaped like a hull, allowing the aircraft to sit directly on the water. The completed prototype had a wingspan of roughly 190 feet. 6 Daimler-Benz DB603 inverted V12 engines were installed across the wing, each producing about 1,750 horsepower. All of that weight had to accelerate while the hull dragged through the water. A conventional aircraft rolls on wheels with relatively little resistance. A flying boat has to push water away from its hull until the wings finally produce enough lift to pull the machine free from the surface. That meant the BV-238 had to survive waves, spray, repeated impacts, and the aircraft's full weight while floating. Once airborne, the same structure had to function like a normal airplane. Only one complete prototype was built. Today, the BV-238 survives mainly through black and white photographs showing the enormous machine resting on Lake Chal. The fuselage sits low in the water, while the wing stretches far beyond it, making the aircraft look more like a naval vessel with wings than a conventional airplane. Near the end of the war, the completed prototype was attacked while moored on the lake and left partially sunk. That ended the project before it could become a fleet. One complete aircraft, 6 engines, and a wingspan approaching 200 feet disappeared almost as quickly as they had arrived. The BV-238 became rare because its story ended before it truly began. The Martin Mars survived long enough to find an entirely different purpose. The Martin Mars was built for the Pacific Ocean. Its original military role was long-range transport. Instead of depending entirely on island runways, it could land directly on water and carry cargo or personnel across enormous distances. The aircraft had a 200-foot wingspan and 4 large radial engines. Only 7 Mars aircraft were built, including the original prototype. But the takeoff told the story better than the production numbers. At first, the Martin Mars behaved like a ship. Its hull moved through the water as the engines built power, throwing spray behind the aircraft while it gathered speed. Gradually, the wings began carrying more of the weight. The hull rose higher. The drag started to disappear, and a machine that had looked far too large to leave the lake finally became airborne. After military service, several survivors were converted into firefighting aircraft in Canada. That second career gave the Mars an even more dramatic mission. The aircraft could skim across a lake, collect thousands of gallons of water, climb away, and carry that water toward a wildfire. A machine originally built to move military cargo was now lifting part of a lake into the sky and releasing it over burning terrain. That became the image most people remembered, a huge boat-shaped aircraft charging across the surface, rising through its own spray, then returning to the fire with a massive load of water aboard. World War II created these giant transports because distance was a serious logistical problem. The Cold War turned distance into something far more dangerous. Could a bomber take off from the United States, cross an ocean, carry nuclear weapons, and return without depending on a nearby base? The Convair B-36 Peacemaker had a wingspan of more than 230 feet. That was large enough to make the already enormous B-29 look as though it belonged to a smaller category. The B-36 was designed around an extreme mission: take off from the United States, cross intercontinental distances, carry heavy weapons, and return without depending on overseas bases. To do that, it used 6 Pratt & Whitney R4360 piston engines in a pusher configuration, with the propellers mounted behind the wing instead of in front. Later versions added 4 General Electric J47 jet engines for additional performance. 6 turning, 4 burning. Together, they gave the later B-3610 engines on a single airframe. With the jets operating, the B-36J could reach about 435 miles per hour. The outside was strange enough. The inside was even more unusual. 2 pressurized crew compartments were separated by the aircraft's bomb bays, and an 85-foot tunnel connected the forward and rear sections. The tunnel was only about 2 feet wide, so crew members could not walk through it. They had to lie flat on a small wheeled cart and pull themselves along using an overhead rope. The same cart could also carry meals from the rear galley to the crew in front. The airplane was so long that moving between crew areas required a small transportation system inside the fuselage. Maintenance was just as extreme. Each of the 6 piston engines had 28 cylinders. With 2 spark plugs per cylinder, the aircraft carried a total of 336 spark plugs across its piston engines alone. Flying it was not effortless either. One B-36 pilot compared the experience to sitting on the front porch and flying your house around. The description fit. The pilot sat at the front of a machine with a 230-foot wing, 10 engines, multiple crew stations, large bomb bays, sleeping areas, and enough internal distance to require a trolley. The B-36 never dropped a bomb in combat. Its main weapon was the threat that it could. During the early Cold War, its range and payload made it a major part of American nuclear deterrence. But the aircraft arrived at an awkward moment. Jet engines were improving rapidly. Aerial refueling was becoming practical, and faster all-jet bombers were already under development. The B-36 reached the peak of long-range piston-powered bomber design just as that entire type of bomber was becoming obsolete. By the end of the 1950s, the U.S. Air Force was replacing it with the B-52. The B-36 needed 10 engines to perform its mission. The B-52 proved the next generation could do it with 8 jets, and keep doing it for decades. The Boeing B-52 Stratofortress first flew in the early 1950s and was originally built for a Cold War world of long-range nuclear missions. The B-52H has a wingspan of 185 feet. 8 jet engines hang beneath the wings in 4 paired pods, each producing up to 17,000 pounds of thrust. The aircraft can reach approximately 650 miles per hour and carry up to 70,000 pounds of payload. But the real reason the B-52 remained useful was not one single specification. It was the ability to change what it carried. The original aircraft was designed around strategic nuclear weapons. When the mission shifted toward large-scale conventional bombing during the Vietnam War, many B-52D bomb bays received the Big Belly modification. An unmodified B-52D could carry 27 conventional bombs inside its bomb bay. With Big Belly, the same internal space could hold as many as 84 500-pound bombs or 42 750-pound bombs. The aircraft had not simply received new weapons. Its internal structure had been modified to accept a completely different kind of mission. Decades later, the process continued. The B-52H's internal weapons bay was rewired around a conventional rotary launcher that could carry and communicate with up to 8 modern precision-guided weapons inside the aircraft, in addition to weapons carried externally. The bomber moved from Cold War nuclear weapons to mass conventional bombing, and then to digitally controlled precision weapons, all within the same basic airframe. Its landing gear was unusual as well. The main wheels could be turned so the aircraft could touch down, while its nose pointed slightly into a strong crosswind. Small support wheels near the wingtips prevented the long, flexible wings from touching the ground. From certain angles, the B-52 could look awkward and almost fragile. Then the bomb bay opened, revealing how much firepower had been repackaged inside an aircraft designed in the 1950s. The B-52 did not survive because it remained unchanged. It survived because generations of pilots, weapons, and onboard systems changed around an airframe that remained stubbornly useful. Its range, payload, internal volume, and ability to accept new equipment kept it relevant long after many younger aircraft had disappeared. The B-36 represented the end of one technological age. The B-52 learned how to survive through several. But bombers were only one side of the Cold War scale race. The other was about moving tanks, vehicles, and entire military units across continents. The Antonov An-22 was not designed around perfect airports. It was designed around the possibility that the runway might be remote, rough, or completely unpaved. The aircraft first flew in 1965. Its wingspan stretched a little over 211 feet, and it cruised at roughly 360 miles per hour. It achieved that speed using 4 Kuznetsov NK-12 turboprop engines, each driving 2 enormous propellers that rotated in opposite directions. The unusual propeller system produced one of the most recognizable sounds in aviation, but it existed for a practical reason. The An-22 needed enough power to move tanks, military vehicles, oversized machinery, and troops into distant regions. Its landing gear spread the aircraft's weight across many wheels, allowing it to operate from surfaces that would be unsuitable for many other heavy transports. That mattered across the Soviet Union. Delivering equipment to a polished international airport was not always enough. The aircraft had to reach locations closer to the actual mission, and sometimes the cargo did not fit inside the airplane at all. Antonov used modified An-22s to carry enormous components for the An-124 and later the An-225. Large wing sections were mounted directly on top of the fuselage for transport between production facilities. The An-22 was so large that it helped build the next generation of giant aircraft by carrying pieces of them on its back. It was more than an oversized transport. It was one of the machines that made even larger transports possible. The An-22 was built to reach difficult destinations. The C-5 Galaxy was built to move a military force through a global airbase network as quickly as possible. Before a vehicle enters a C-5 Galaxy, the aircraft lowers itself toward the ground. Its kneeling landing gear brings the cargo floor closer to standard truck bed height. The The nose rises, the rear doors open, and ramps create a route directly through the fuselage. Then the loading begins. A truck moves slowly onto the ramp, while the load team watches the clearance around its roof, tires, and sides. Inside the cargo compartment, each vehicle must stop in the correct position, so the total weight remains properly distributed. The vehicles are secured, the ramps are removed, and the aircraft raises itself back to its normal height. Only then does the true scale become clear. The C-5M has a wingspan of 222 feet, 9 inches. Its cargo compartment is 143 feet, 9 inches long, and maximum takeoff weight reaches 840,000 pounds. The front and rear loading system allows vehicles to travel through the aircraft instead of reversing through the same narrow opening. That matters when the cargo includes armored vehicles, trucks, or complete helicopters. One vehicle follows another into a cargo compartment longer than many buildings. Ground crews secure the load, the giant doors close, and an entire collection of military equipment leaves the ground in one flight. That is what makes the C-5 more than a large cargo plane. It is a deployment machine designed to move a military force before slower ships or ground convoys could reach the same destination. The AN-124 would take heavy airlift into a different world, one where the customer was not always a military force, and the cargo might have been designed to stay on railroad tracks. On June 9, 1994, a diesel-electric locomotive weighing roughly 240,000 pounds arrived in Dublin, Ireland. It did not arrive on rails. It arrived inside an Antonov N124. The locomotive had been built in London, Ontario for Irish Rail. Normally, equipment that heavy would travel across the Atlantic by ship, but the first locomotive was needed early for clearance testing and crew training. So it was taken to an airport, loaded into one of the largest transport aircraft in service, and flown across the ocean. That single mission explains the AN-124 better than a long list of specifications. A locomotive is designed to spend its life following steel rails. Before this one could begin working in Ireland, it had to become air cargo. The AN-124 first flew on December 24, 1982. It was developed as a heavy strategic transport, and later versions could carry roughly 330,000 pounds of cargo. That capacity made it valuable far beyond military operations. Helicopters, industrial machinery, emergency equipment, and loads that normally required ships, rail transport, or special road convoys could be moved across continents in a single flight. The 1994 locomotive mission was not simply a publicity stunt. Flying the first unit to Ireland allowed testing and training to begin before the rest of the order arrived by sea. The aircraft had compressed weeks of shipping and preparation into one flight. That became the real identity of the Russlin. The C-5 was built to deploy military equipment through an organized airbase system. The AN-124 became the aircraft called when an oversized machine needed to cross the world before the normal transportation system could move it. A locomotive on the ground looks permanent. It belongs to rails, stations, and freight yards. Inside an AN-124, it became another piece of cargo waiting for takeoff. From a 6-engine wartime transport, losing 14 aircraft in a single interception, to an airlifter carrying a 240,000-pound locomotive across the Atlantic, these machines forced military aviation to grow far beyond normal scale. Would you rather crawl through the B-36's internal tunnel, or watch the Martin Mars lift part of a lake into the sky? Subscribe to Megamass for the next machines built beyond normal limits.